Two-compartment model after extravascular administration. In the previous video, I explained what is two-compartment model. That is, body is divided into two compartments, central compartment and peripheral compartment. Central compartment comprises of blood and highly perfused tissues, for example, heart, lungs, endocrine glands. However, the peripheral compartment comprises of shallow tissues and deep tissues. Shallow tissues are poorly perfused tissues, for example, large muscle mass, skin, adipose tissues, and deep tissues are negligibly perfused, for example, bone, teeth, hair, ligaments. Starting from today's topic, that is one compartment model after extravascular administration. In this model, we are going to look into that the drug undergoes three simultaneous processes: absorption, distribution, and elimination. We are going to discuss it one by one, starting from first one, that is absorption phase. Absorption phase, there is net transfer of drug from absorption site into the central compartment. The upslope of early segment of curve is due to greater rate of absorption than distribution and elimination. Second one is distribution phase. In this, as drug is absorbed from absorption site, the drug concentration in plasma reaches to maximum Vmax at Tmax. After Cmax, the rate of distribution dominates over elimination and later becomes equal. The third one is elimination phase. In elimination phase, there is rapid decline. After Cmax, the elimination rate predominates, yielding the log linear segment of the curve. Residual curve. The method of residual is well explained in the previous video. Residual analysis becomes more complex after extrapolation of the terminal portion. The residual curve needs further swiping of curve, yielding three y-intercept A, B, C. Original terminal curve represents slowest exponent, that is elimination. Residual curve is intermediate one, which shows distribution, and the last one is exponential curve, which is the fastest one, that shows the rate of absorption is greater. In this graph, you can see ABC points. Equation of model. Here you can see the equation of model comprises of absorption, distribution, and elimination. And ABC, how we calculate ABC. F stands for fraction of dose absorbed, D is equals to dose administered, alpha, beta are hybrid rate constants for distribution and elimination. Illustration of model. Illustration of model is, there is addition of first order input rate constant Ka that depicts the absorption of drug from the site of administration into the central compartment. Here is absorption Ka, K12, K21, K10 and K20. In the previous video, I have explained every constant. Pharmacokinetic parameters we are discussing in this model is area under curve, rate constants, K21, K10, K12, half-life, volume of distribution, fifth one is clearance, sixth one is ABC, then absorption, rate constant, similarly distribution rate constant, elimination rate constant, and last is Cmax and Tmax. Starting from first one, that is area under curve, can be determined by model independent trapezoidal method or by model independent integration method. I have explained trapezoidal method in previous video. Here we are discussing the model independent integration method. AUC is found by this formula. A over alpha, that is of distribution, B over beta, that is of elimination, minus C over Ka, that is of absorption rate constant. ABC, we can find ABC values by this formula, by putting values in this formula. Third one is elimination rate constant, that is K elimination or beta. From the slope of elimination curve, we can find the elimination rate constant log natural y2 minus y1 over x2 minus x1. Distribution rate constant, we can find the distribution rate constant alpha from the slope of distribution curve, similarly like for elimination curve. So K alpha is equals to log natural y2 minus y1 over x2 minus x1. So fifth one is absorption rate constant, and it is also found by from the slope of absorption curve. K absorption is equals to ln y2 minus y1 over x2 minus x1. So sixth one is rate constants, that is micro rate constants are needed for description of two compartment model after extravascular administration, K12, K21, K10. Seventh is volume of distribution. 3 volume of distribution, such as volume of distribution, volume of central compartment. Third one is volume of tissue compartment, can be determined by volume of distribution is equals to volume of central compartment, K12 minus K21 over K21. However, volume of central compartment we can find by this formula, and volume of tissue compartment is found by subtracting volume of distribution minus volume of compartment, central compartment. 8 parameters half-life, absorption, distribution, elimination half-lives are calculated as, simply we are dividing 0.693 over everyone's rate constants. 9th is clearance. Clearance calculated same as we calculated for two compartment IV administration model. You can see from there. And Cmax and Tmax are calculated directly from the graph.